All right, folks, if you remember, we finished on me not being able to do anything on my laptop because I ran too many DAGs. In the meantime, I moved to the patio because it's too nice outside, and even though I'm sick, it's warm, so I'm sitting here. Anyway, let's look at what we have here. I have the results of running those, what, six, seven, eight different ads. And you see some of them as are red, some of them as are green. So if I look at the red ones, I will see what we saw in the last video. This is text exited with return code negative. Return code 9, which is not enough resources, right? And this is actually, like, I did not plan on this. In fact, I probably would have preferred that it didn't happen, but I think this is instructive for you to see that these tasks just succeeded just fine, and these ones were out of memory. And the idea is, right, that Overflow is trying to run these all these DAGs like that are backfilling from November 1st, which is our specified start date, to today. Airflow is backfilling those and trying to run them all at the same time. And so it's trying to download the data at the same time, then it's trying to process it all at the same time, and then it's trying to load it all at the same time. And eventually it just runs out of resources. And a better way to run Airflow would be not on my $400 laptop, but say on the virtual machine in the cloud. And that's a topic of another video that I'm working on. But for now, we see that at least like the code that we wrote is successful, even though it might not be enough resources on my local machine to run it. So I'm going to open VS Code again. I closed it because I restarted my computer. So remember where we were? We were at the stage of the loading data into the data warehouse, and we had this huge conversation about how where is it? About how to handle duplicate data, right? Because when we retrieve the data from the website, we get all of it, right? And we shouldn't try to load all of it because we're going to get duplicate data. And one way to do it is to just have a task that removes all the tables, starting with the fact table, because that's the table that references other tables, and remove facts and then dimensions, and then reload them. And a different way would be to try to go into the table, see what data is already there, and try to load the difference. Which one is more performant actually depends on your system. Like, it seems like getting a bunch of data and then loading it might be too performance intensive, but if you think about it, we already have all the data and we have to go through all of it. And for each record, we have to see if there is a corresponding record in the database. And that actually might be worse, right? And we talked about how an alternative way would be to just retrieve only a bunch of data that we need, but it's not possible with how we retrieve it currently, but it is possible with how we retrieve it in a different way. So we had this load script, right? And this is where we introduced a new method to handle duplicate data. We said that a method that I just pulled from Pandas documentation, inserting conflict do nothing. And we're going to use this method to load all of our dimensions. For facts, it's not necessary, right? Because facts are always going to be new. The problem that we had with dimensions is because our data had mixed information about facts and dimensions. It was like presented as a fact data, but we don't know whether the information about an animal is new or not. So I'm going to make a separate function for loading fact data. And there I will not need this. And I will not need this. And I can just append. Actually, I can just replace. Yeah, I can just replace. Because currently I'm just retrieving the entirety of data. If you were retrieving only the data for the minutes of a certain date, then you would append. Because we're retrieving everything, we replace. So I'm going to do this. And then I'm going to go to my DAG. Also, I just noticed that I called it outcomes instead of outcomes, but whatever. And currently I'm only loading animal dimension. What I'm going to do is I'm going to add tasks for all my dimensions. So I have days dimension. And if you're wondering if there is a better way to do it, there is. But once again, for time reasons, we're going to keep it as is. Then my other dimension is outcome types. We can create a better way to have it like a parameterized tag for maybe a group of these tags, but just getting. And so these are, I think I replaced everything I need to. And then I want to load outcomes fact. And what did I call my function? Load fact data. And my Parquet file was called, I don't remember what. FCT outcome. FCT outcomes. Cat. I had an extra space there, which I removed. Table FCT outcomes, and we won't need a key because for the fact table, we are just replacing the entire table, and we're not doing this. Trying to find the key if it exists, and if it doesn't, replace. All right. So one more thing we need to do. The reason I'm making these into separate tasks instead of loading them in one task is because they can technically be executed independently. The animal loading animals dimension, loading data dimension, loading outcomes dimension, they can be executed independently, and there is no reason for it to be in one task if we can distribute it. And actually, I can tell Airflow that these can be executed after transform, but all at the same time by saying that after transform, I can have an array of tasks. And this is takes tapes. Right, so this over here takes like first extract the data, then transform the data, then types, then run these 3 load functions, and then I want to load the facts, and I have to load the facts after I load the dimensions because facts deep read is dimensions. All right, so I'm saying done, and now I'm going to run it, and it will not hopefully run out of resources because I'm only going to run it once instead of running it 6 times simultaneously. Yeah. This has always happened. Okay, so this is actually fine because it's just a mistake in some DAC specification somewhere. Load CT data. Oh, I did not import it. I see. I did not import. Oh, nice. Hopefully this will work. There we go. So we have the DAC running. And yeah, let's see if it will work. So we see that in the graph, we already see that it has 3 dependencies: load outcomes, load dates, animals that lead to load outcome facting. While I was doing this, I can tell you that I think my preference would also be do the transform for each table in a separate task. Again, because that can be done independently. This can be, for example, each one of those can be an independent Spark job. I don't need all the dimensions transformed at once. So my preferred way to do this would be also to break transform into 3 different tasks and then have a dependency so that load outcome types dimension only happens after transform outcome types dimension and so on. But that's for you to do, not for me. I will press my pause button and wait for it to complete. Okay, I actually did something really stupid and it didn't complete. And if I go to the logs, it actually tells me how stupid I am. It tells me that I'm using dates ID, whereas the name of my field is date ID. So I'm going to go and fix that. Date ID and also outcome type. And yeah, outcome type was in the second one. It tells me like, oh, you have this name, but maybe you meant this other column, which is very helpful, which is very condescending. All right, I'm going to rerun this again. It hasn't finished yet, but I want to show you something. Look at how what happens here on the left, where load animal dimensions is still running. It's still like bright green instead of dark green, but the others have completed. And that's totally okay, right? They completed before the humans. It's because the tasks are independent. But the fact task, the load outcome fact task, is still waiting for all 3 to complete. And hopefully it's done by now. And it's wrong. So what does the log say? It's saying requires position marking key. Oh, I know what that is. It's because I didn't tell you it's here. Don't you enjoy seeing like this in real time? I said I run this several times and this still happens. This is software development. And there we go. Finally, after many tries, we have our entire thing working and entirely green. All right, so we download the data, save it into local storage. We read it from local storage, transform model it, save it to local storage. Read it from local storage again, put this into data warehouse for dimensions and effects. So to reiterate what kind of improvements we could talk about here. First of all, the main one is to not use local storage, but use cloud storage. It's a bit annoying to manage credentials, and I also didn't want to show you my Google password, so there, you can search for it yourself. Second is breaking up the transform operator into multiple operators for each of the dimensions that can be run parallel. Third, Dockerizing every Python operator. So not having Python operators actually, and orchestrating them with, say, Kubernetes, or having a Spark operator instead of a Python operator, so that Overflow sends a Spark job to Spark cluster, and Spark cluster processes the job instead of one Airflow, which is, as you can see, runs out of memory very easily. Finally, the loading into the table currently is kind of very analog. I just tried to work around the toSQL function. I don't have to do that. In fact, maybe what I could have done instead of loading the extracting into the local file system, I could have extracted into a database already and do all my transformations in a database using FocusNetDB, and then my load outcome types Python operator would become like GBT functions together with Postgres, such as load the data into Postgres. Airflow has special operators for Postgres, for like GCP, for GBT, anything you can think of. And using those operators, depending on what storage you start with, what storage you end up with, is much more efficient than just using Python operators and executing them inside Airflow. And finally, I would start my very first step, the extraction. I would not extract. I would, on the first load, as I just built the warehouse, I would extract the bulk data, but on the successive loads, I would just extract the data for the last day. And so, like, through the API, make this a parameter for the query, and just load the data for the last day. And this would also, for example, take care of the out of memory problem. All right, so that's it. That should get you about 80% towards completion of lab 3. What it doesn't get you is, like I said, using cloud and breaking up the transfer function, but the rest of it is covered here. And maybe in the next lab, we'll try to actually pull the Python operators into Spark. Let's see if I can make this contained within 2 hours. All right, thank you all. I'm sorry I can't be there with you tomorrow. And yeah, have a good week.